Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, I'm going to be working on something I haven't worked on in a little bit of time. It's an Apple II, specifically an Apple IIgs. This machine was sent in by a friend of the channel, James, who also gave me a good number of computers, including the Amiga 3000, Amiga 1200, and there's some more machines that I haven't worked on yet. I haven't tested this 2GS yet, but from my understanding, it does not work. So let's figure out what's wrong with it and see if I can get it working. And without further ado, let's get right to it. What we have here is a very yellowed example of an Apple IIgs. The GS in Apple IIgs stands for graphics and sound, and this was Apple's upgrade of the venerable Apple II line that first introduced in 1977. This computer came out around 1986 and did offer substantially better graphics and sound than all the previous Apple IIs before it. The G, or graphics side of things, brought with it 320 by 200 and 640 by 200 resolution graphics with a palette of 4096 colors and RGB output. And the sound part of it, or the S in GS, was an Ensoniq synthesizer that had 64K of dedicated sound RAM and was wavetable synthesis. Very capable and really kind of underutilized, to be honest, with Apple IIgs software. Both the graphics and sound were a substantial improvement over the original Apple II, but what's really cool about this machine is it is fully backwards compatible with regular Apple II software. But the backwards compatibility, even though it was very good and very capable, was a bit of an Achilles heel at the same time. And that's because a lot of companies just wrote software for the Apple II because that was the largest install base, and they didn't really target the 2GS specifically. So you saw a lot of these in schools, for instance, with the RGB monitor, but they were just running regular Apple II software and really didn't take advantage of any of the additional features this machine had. Apple did give this computer a processor upgrade. It has a 65C816 inside, which is really a 6502 with sort of 16-bit extensions added onto it, and it's a little bit faster. You can run Apple II software at 2.8 megahertz, the original Apple II software, and it is faster, or you can set it into a compatibility mode to run at 1 megahertz, which is the original clock speed, and that just makes it a really good, suitable machine to run original Apple II software. It's really easy to get in these things, a lot like the Apple IIe has those two buttons you just push. Also, like the Apple IIc, there's a whole bunch of built-in ports. This was the first computer to introduce ADB, or Apple Desktop Bus, to the world, I suppose. So the keyboard and mouse is ADB, which is compatible with the Macintosh SE and pretty much all Macintoshes for quite a long time until they moved over to USB. Starting on the right side, we have a power switch with the mains input. There's a regular power supply inside. It's similar to the 2E power supply, but not exactly the same. As a different connector on it. There's an ADB port, composite video, RGB, floppy drive, joystick, and we have a printer and serial port, and this is RS422 or RS232 compatible with the right cable, and there is an audio output jack. And unfortunately, for whatever reason, Apple only gave this thing monaural output through this jack. And it's kind of weird because the synthesizer that's using the 2GS does support stereo sound. It's just not native. You have to use I think it's like kind of a MUX to split the audio out. So there were third-party cards that gave you stereo output plus sampling capabilities for the machine, but for whatever reason, originally it only had monaural. For whatever reason, this machine has a plate that has a hole in it. Not quite sure exactly what's going on with that. I don't think that would have been a stock. And yeah, you could put a screw in here to try to keep people from opening the case, probably in a school setting, because a lot of schools did buy these. And with the top release, by having pushed those two buttons, the top just sort of comes off like so. And we can see that this thing has been exposed to moisture in the past, so there's definitely a little bit of rust in there. But you can get a look at maybe more the original color this thing would have been before the yellowing happened, just sort of a grayish platinum color. Before we take a look inside this machine, there was a note attached to it, and it says, "Hi Adrian, please accept this donation for the channel and or community. Here are some notes on this Apple IIgs. This machine is from Goodwill, the power supply is from eBay and was described as sporadic. The Varta battery has been removed. Included in the case is a new cap kit for the board and the power supply." And yeah, sure enough, here's a cap kit. And here's another one, and this comes from Console 5. James goes on to say, "I've made an initial rudimentary attempt to clean the grooves in the top case. This is such an awesome task and so much fun. Highly recommended on this and low profile Amigas." All right, well, let's grab the top case here, which is stuck up on a wire. It looks pretty clean. Judging by the fact that there's this corrosion inside, this thing was probably stored in a bad situation, and I guess the power supply might have been missing, because James indicated this is a replacement power supply. One of the things I do sometimes, I have to tell you, is, well, I take this outside and I use simple green and just sort of spray all over this, and then use a toothbrush, and it goes pretty quickly, and you can just use a hose to like hose off the computer afterwards. Now, this shield in here can rust a little bit, and it's kind of annoying to be in there, and this one is already rusty. It is plastic staked in, so you can't just remove it very easily, but if you do pull it out, you can just leave it off. It's not necessary for operation of the computer, it's just an FCC shielding thing. I do see a little bit of evidence like in the side grooves here that's still a bit dirty. So yeah, James or anyone else who's watching, just like spray it down with some cleaner, even Windex is fine. Let it soak a bit and just use a toothbrush and just go through it, just hose it off. Take it in the bathroom into the bathtub if you don't want to take it outside. But that's the way I always clean these, and it makes pretty quick work of it. All right, well now looking at the computer, it looks okay inside. Now, one of the things you have to be careful of is these power supplies can have VARDAs in them. To pull these out, you just disconnect the power cable. And when it comes to Apple IIe compatibility, when it comes to the power supply is very much the same. It's just the connector is different. And the motherboard down there, if you kind of look right there, actually has a footprint for the same connector that the Apple IIe uses. And that's because Apple sold a kit where you could use this motherboard in an Apple IIe case, and you just reused your original IIe power supply. And those kits actually came with that connector populated. In addition, this keyboard connector was populated, and that's because you could reuse your Apple IIe keyboard as well. Obviously, this thing, as I said, it has an external keyboard through Apple Desktop Bus, but it does support an Apple IIe keyboard as well. Now, to remove this from the case, all we have to do is just pull this lever here on the front, which you really couldn't see, but it's this lever right here. And then the motherboard, or sorry, the power supply comes right out. Well, we can see even this is all corroded. So that really tells us that this computer was exposed to a good amount of moisture. The battery would have been here. It's already been chopped out by James, so that's good. So no leakage or anything like that. I don't really see any other main issues on this board. When it comes to recapping the main motherboard, I mean, I've never done it myself. I never felt that there was any kind of reason that these caps are good quality. Now, if we look at the date codes on here, 1987, 87, so we can estimate that this computer is from around 1987. In fact, there it is, 1987, 52nd week, very end of the year. And look at all that crusty corrosion. There are two revisions of the Apple IIgs motherboard, and this being a 1987 machine, so just like a year after it was released. This is the earlier of the two revisions. I don't remember all the specifics of what were on the later revisions of motherboards, but the one main difference is that this one only has 256K of RAM, well, usable RAM. So there's 128K for the Apple II software, 64 plus 64 auxiliary, and there's an extra 128K of RAM over here. It does also have 64K of RAM right there for sound, so that's not really counted in the system memory since it's not directly addressable by programs. The later revisions of the motherboard had quite a number of changes on them, including having more memory on board. I can't remember how much those have actually on board, but it might actually be a megabyte. But to expand this with more RAM, you put a RAM expansion card in this little extra connector over here, and there's modern ones you can buy, or at least you could, that would give this thing like 8 megabytes of RAM plus whatever's on the motherboard pretty easily. These slots are just standard Apple II expansion slots, so any cards for the Apple II can go into these slots. Although, because this thing has a bunch of integral peripherals, just like the Apple IIc, there's a chip on here called the slot maker, which is this one right there, and that will select whether you have the internal peripherals being selected. For instance, for 5¼ inch floppy drives, that's slot 6 normally on Apple II, and the slot maker will route that through the built-in floppy connector to use just internal floppy drives, or sorry, external floppy drives. But if you do want to use a card in slot 6, you have to go into the control panel, which is a piece of software that runs in the ROM that you can just access anytime, and switch over to the internal slots. The topology of this machine is just an evolution from the older Apple IIs. We have a super serial chip here from Zilog that handles both of the serial ports. That's the aforementioned slot maker. These integrated WAS machine. This is the chip that handles the floppy drive interface, including the 3.5-inch stuff. There's a microcontroller that handles the ADB, or Apple Desktop Bus, and there's a keyboard glue logic chip here, which I assume is to basically mix the signals that come out of the ADB to the Apple IIe keyboard. There's the ROM. There's our CPU, the 65C816. This chip is labeled Mega 2, and this is what brings all the Apple II compatibility to the 2GS. It's essentially an entire Apple IIe chipset, all in this single IC. This chip is the VGC, so you can think of that as the video chip. The Mega 2 actually generates video for Apple II standard text mode and stuff like that. This is what handles all the additional graphics modes and can apply color for text and background and border onto the Mega 2 standard Apple II monochrome graphics. This chip here says FPI, and to be honest, I don't remember exactly what that even is used for. On the bottom edge of the board, we have some sound circuitry, so there's some op amps there, sound chip, the glue logic, and the sound RAM. Now the motherboard itself actually extends down to this area of the case, which can be a little bit of a problem if you are trying to replace some of these chips, if there's bad RAM, for instance, and notice there's just not a lot of clearance there. So you either have to kind of Dremel away the plastic or put the replacement chips directly into the motherboard without using sockets. Obviously, these are okay, and these are okay, but yeah, if these are bad, then, well, that's a problem. And looking at these RAM chips, these are those TMS 4464. So 2 of those chips is 64 kilobytes, very similar to the chips used on short boards. These often fail, and when they do, they get really hot and the computer won't work. That could easily be what's wrong with this computer. The 2GS itself is known to be a very reliable computer. Apple did not use any leaky caps on this thing like the later Macintoshes did, and the custom ICs that are on here are all made at a really good fab that doesn't seem to have any of the issues like MOS chips have on 64s, for instance. And really the only issue I've ever run into personally working on this is the RAM. And I suppose we could be having power supply issues as well. So I think the first thing we need to do is I need to power this up and see exactly what it does. And hopefully it is actually broken because that's what James said it. But if it works, then, well, this is gonna be kind of a boring video, isn't it? Multimeters at the ready, power supplies off to the side. If this thing works, we should hear a dong, that's the beep of the 2GS, the stock beep that is. Let's see what happens. Oh, got to turn on the power strip. Okay, we got nothing. But let's just check the voltages real quick. 5.024 looks perfect on the orange wire. All right, we're getting 11.6 on the 12-volt rail. We should have a minus 12. That looks good. And minus 5. All look good. This is making kind of a hissing noise. Power supply, that is. I don't think that was coming out of the speaker. I heard a tick out of the speaker, but the computer wasn't doing anything. Classic symptom here of bad memory. I think the very first thing I need to do is we need to look inside this power supply and we need to check to see if there's a reefa in here, because if there is, I need to get that out. I don't want that letting the smoke out in my basement right now. No, thank you. I find really funny, and I've seen these same power supplies inside Apple IIgs, is there's a provision for a fan that was just never installed. It's there, but never was actually used. So this is a totally fanless computer, and it can get pretty toasty, just like Apple IIgs can when you have a whole bunch of expansion cards in there and the thing is just sitting there kind of baking. This power supply, by the way, model number 6990126. I've only worked on a few of these, so I don't remember exactly how to take them apart. I'm not sure if these screws were supposed to come out, actually. I think the only ones that were supposed to come out were the ones on the top. I think the side screws are hooked up to a transistor or something like that and uses the case as a heatsink. And I could see a little bit of a thread locker on there. So that's why I don't think you should take that off. So with those 2 screws on the top out, I twisted the here and that sort of lifted this part of the power supply. It's a very tight fit though. I'm gonna spend a second to get this cable gland out. I don't know if that has to come out first. I don't think that mattered. Well, I've been struggling trying to get this apart for quite a while. I've taken apart other 2GS power supplies and I don't remember them being quite this hard. The main issue is that this top cover slides down into the bottom and it holds on very tightly on these points, but then there are 2 little sort of tabs that poke through and you have to bend these out before you can start to kind of lift this out. And even though I've kind of started it, it's just holding on for dear life. This does not want to be serviced at all. There we go. With a bunch of prying, I think this is pretty much off. Almost, actually. No, not quite. Still holding on over here. There we go. That is it. It is out. And yeah, there's a reefa right there. So at least it has one. Interesting. I thought it would have had another one right here in this position. It says C1, but it doesn't appear to. And then as for the screw that I took out right there, yeah, there's a nut there and you can see it's held on by some thread locker, which is good because it would have fallen down otherwise. I didn't need to take it off to get the lid off, but you do need to take it out to get the power supply board out because I need to get that out anyways to get this reefa out of there. Now, please be aware if you've turned on a power supply recently, like I have with this one, opening it up can result in you getting a shock because this large cap right here, that can hold a good wallop. And there's often a discharge resistor, but sometimes that's failed or there isn't one, and you can get a big old zap from that. With the 2 screws on the heatsink out, there are still some fasteners holding down the entire board. Right there and right there. And this should be free now. Of course, it's still connected over here, but I'm just going to leave that and just pull this out. Now that I have that cable gland out, I can lift this part of the board out. With a little bit of bending and prodding, the board comes out. This is the area where that cap is. It's right there. So let's just check what the voltage is across it, just so we can see if this is dangerous. And it is not. You can see that there is no charge at all in this big capacitor right there. Okay, so see these pads right here? That's where I think another reefa would potentially be. But for whatever reason, there isn't one there, and there's just this 0.01 microfarad Y-class cap on there. It looks like it's going between earth, that's this part here, the case itself, and it's going to the neutral wire. If this starts to become leaky because it's going between earth and neutral, it doesn't really pose much of a danger. I am still going to take it out though. I don't want to leave that in there. And I'm getting white stuff on my fingers because there was a little bit of grease there between the heatsink and the case. Either way, I'm pulling that out of there, and I'll just replace that with a correct Y safety cap. So I swapped out this reefa cap for a Vishay Y2 class capacitor in that same position. Now the letter that came with the computer mentioned that, of course, this power supply was sold as intermittent. Now that could mean all sorts of things, but one of the symptoms of intermittency is that it doesn't always start. And when that happens, it's usually the small capacitor that's on the high voltage side, which is over here. This is the bootstrap cap. And what this cap does is it slowly charges up off of mains when you first turn on the power supply. It usually takes like a second or so. And then that voltage is used to run the actual circuit, which drives the switching transistor, which actually starts switching the high voltage DC through the transformer. It gets rectified, turned back into DC, and then that feeds back and actually runs this circuit. So the bootstrap cap is really needed to have the whole switch mode power supply start. If this capacitor gets baked or loses value, and of course it is near this hot resistor, then the power supply might not start every time. It obviously turned on fine when we tried it, but could be that this is bad. So I need to check that just to make sure that it's okay. Other potential problems are we could, of course, easily just have some bad solder joints. I'm just giving this thing a quick once over, and I really don't see any bad solder joints, but sometimes they can be really difficult to see. So anytime you have things with pins that stick to the board that get hot, like these components and the other heatsink and transformer, it's always good to reflow those. And if you have a connector that is used to feed the mains into the power supply, you might want to check that as well. Although in this case, it's wires, and those look totally fine. And I think the first thing we need to do is let's test out that little bootstrap cap, and I'm just going to use my LCR meter to do this in circuit. I'm going to set this to ESR mode. I'm going to set it to test it at 100 Hertz because, well, 120, because that's actually what this thing is going to be charged up with off of mains, because it's probably like a single diode that charges it. And we are getting 194 microfarads, 0.8 ohm ESR, and that's a 220. Looks like it's a 10 volt cap. I'd say that's fine. There's nothing wrong with that cap. Now we do have the cap kit for the computer. Let's check to see what the cap in the cap kit is, what the value is of it. I think, let's see. This is the one for the power supply, obviously. This is going to be the cap that they want us to use. It's a 220 microfarad Rubicon at 16 volts. Let's pop this into the tester and let's just see what this actually tests at. 0.3 ohms, 209 microfarads, so it's a little bit higher and the resistance is a little bit lower. I might as well just swap this out since I already have the desoldering iron all warmed up. But I don't think I'm going to change any of the other caps. I mean, you can obviously check them. There's nothing leaking on here. You can just see the size difference between these two caps. That's the difference between 1987 and 2026 capacitors. So I'm just going to spend a moment to reflow some of these joints, and then I'll put this thing back together. I think it'll be working well. All right, I went ahead and I reflowed all the joints that I thought could be a problem, although I didn't see any with cracks, so I don't think there was a crack joint problem on here. So I guess I'll just need to use this power supply to see if it's actually reliable or not. One thing that's funny is there was an extra cap to replace this reefa already in the cap kit, so I didn't need to take one from stock, but that's okay. And it does look like all the caps that came with this cap kit from Console 5 are decent quality Rubicon or Nichicon caps. So that's nice. Although personally, I kind of feel that when you have caps from the 80s, like in this power supply, they're often better quality than the new stuff you can get today, unless you buy the really high quality stuff. And this stuff, if it works, why change it? That's what I think, at least. You know, your mileage may vary. You can do it differently, however you want to do it. All right, I do need to put a little bit of thermal compound on here before I reattach this, because obviously it's using the case as a bit of a heat sink. When you put this board back in, you just have to make sure you get it into the slots over on this side, because there are some slots that hold the board in place. And then remember, there are the two fasteners. I didn't mention it earlier, but this power supply is made by Aztec, and I'm pretty sure I've seen different designed power supplies inside the Apple IIgs They don't all look exactly like this, but generally these switch mode power supplies are very similar to each other just because, well, it's a simple design from the 80s. Modern power supplies and computers are a lot more complicated than these old things just because they have power factor correction and all sorts of other features for efficiency that, well, this thing does not have. A bit of the grease for the bit of the heatsink compound sort of leaked through the screw holes. I'm just wiping that off so I don't touch it with my fingers. All right, so all that's left to do is to put this cable gland back in, well, get this top cover back on, and I'm sure that's going to be annoying and difficult. I think the way it works is you push this side into those clips there, and then you got to get this down. And of course, these things here make it really difficult. Oh, wow. Oh, there you go. That side's in. There we go. Okay. Just push hard. Oh, of course, I messed it up on this side now. This thing's like a puzzle. All right. So we push that down like this. Got to make sure we do it on both sides here. Like that. There we go. There we go. There we go. It's all back together. Older power supplies from Apple are way, way easier to open than this thing was. There we go. It's all back together. This tool makes getting this gland in there really easy. Now, you might be tempted to try to power this up just on the bench like this, like to bench test it. You can't do that. These old designs with the magnetic feedback circuit don't really work unless you have load on them. So if you try to turn this on, it's going to keep tripping and have weird voltages that aren't going to be appropriate. So you really need to plug this into something to load it up first, either light bulbs or an electronic load, before you can actually measure the voltage and make sure that it's working properly. Or just plug it into the motherboard like we've already done. So pretty much nothing I've done here is going to be dangerous if we try to power up the system. But let's just double check that it still does power up the system by plugging it in. And the multimeter is connected up to the 5-volt rail. Here we go, 3, 2, 1. 5.02 volts. I heard a click out of the speaker, so I know the system is powered up. But the power supply powered up immediately. Let's turn the power off and back on again. So it's off, obviously, and on. There we go. Takes like, I don't know, half a second or a second to power up. Power supply sounds normal. I thought I heard a hissing out of it before. I don't hear that now, although that honestly could have been from the speaker since, you know, proximity-wise, it's so close. I might unplug the speaker just in case. Because if the computer's crashed, you know, maybe the speaker was making weird noise. All sounds normal. Power it off again. Back on. Yeah, it comes right up. So I'm not sure what was intermittent about this power supply, but it certainly appears to be working fine right now. Now, when it comes to the computer not working, we haven't done any kind of troubleshooting on this yet. Obviously, we do have a lot of corrosion, so it's quite possible we have bad contact in the few things that are socketed. So the CPU, ROM, sound chip, and of course the video chip. I also noticed while I was editing up the footage I've shot so far that there's a bunch of corrosion on the ports back there. So that could also pose issues if we plug in like an RGB monitor, for instance, and it's not working. I think what I'm going to do right now, I just turned off the power, is I'm going to pull the motherboard out of the case because I want to do some looking at the situation of the ports and make sure there's no corrosion on the bottom side, you know, because it could be lurking bad traces and whatnot just based on how bad this thing looks. Now, how does this come out of the case? I can't remember exactly, but I think it is all clip based. I think I have to take this piece off first. I think to get that front cover off, you have to just flip these tabs and hopefully this does not break. The plastic on the 2GS isn't as bad as with like those Macintoshes from the 90s where they get so brittle, they just completely fall apart if you just look at them. So there we go, that worked, that came off. And look, that's not corroded. Flipping this back over, we now have access to get the motherboard out. I see a dead spider there. This motherboard is held in by these little clips. This is the one that holds in the power supply, but these ones are for the motherboard. There, here, here, there. And not sure if there's more, but let's just start on these ones carefully. Oh, there's one here as well. Oh, I'm just noticing there's a ton of them right here on the slots as well. There we go. And looks like you just pull away. Okay. So there it is. Corrosion and all. Oh, bottom of the board looks good. Zero issues on the bottom. Zero. This is nice and clean. No crusties. Awesome. You know, it's really funny. I don't even know how many 2GSs I've worked on. Not a ton, but a handful. I've never noticed there's a fan connector there. Or if I did, I just didn't remember. I think that's pretty amusing. Space for a fan, not populated. Fan connector, not used. That's hilarious. Anyhow, what I'm going to do is I have the oscilloscope out, and we're going to try to see if we have a video signal on here. And this is without even plugging anything into the 2GS. We just want to see if it's outputting a video signal. And let's turn this on. Okay, so it didn't look like we had a video signal at first, but we do actually have a video signal. I'm going to switch this into AC coupling, which will bring that waveform down. And we'll exit out of here, and I'm going to change this to 500 millivolts per division, if I recall how to do that. Here we go. And then what we can do is we can move the trigger point down to where the sync pulse is, which is right there. If we zoom in a little bit, there's 10 microseconds per division. Well, that's the horizontal sync pulse. That's each scan line. This is the border region. Let me actually zoom in on this a little bit more so you can see more of it. We'll just move this up. Okay, so horizontal sync pulse, color burst. So it's actually displaying color right now. Then we have the border region, because the 2GS has a border region on the top and both sides. And then this is where the active area of the picture is. So if we had a blank screen with just a little bit of text, you might have nothing on most of the scan lines, and then you would have like a little bit of bumps on some of the scan lines. Well, unfortunately, there's a whole lot of everything on there. So this tells us if we plug in something to the video output, we are going to have a picture. It's just going to be filled with garbage. And that just means the computer is not booting right now. Now, what I'm not sure about on the 2GS is if we take out the CPU, if we're going to get the exact same thing. Why don't we just give that a try as a trial? So power's off. Let's pop out the CPU and let's just see what we see. And the reason why I'm asking that is because I'm just wondering if the CPU has to like initialize part of the video based on code in the ROM, or if you just turn on the computer with no ROM and no CPU, we would actually have some video signal coming out of here. Because my assumption is the video circuitry on this probably runs all the time as long as there's a good clock. So that's telling us there's a clock. And the CPU itself, and wow, this is a crusty socket. Wow. The CPU itself is probably not needed to actually initialize anything. We're going to definitely deoxit this socket when I go to put this back in. This barely comes out of here. I'm just carefully trying to lever out the CPU. Okay, there it is. Oh yeah, I hate these sockets. So let's put that there, and let's check what the video looks like now with no CPU installed. I have a feeling it's going to be pretty much exactly the same. It takes a second for this thing to just come down. Oh no, it doesn't look the same. So with the CPU out, we have no image at all. I mean, we still have like a video signal and it looks like a color burst there, but there is no border, there's no nothing. That implies that this was actually, and powered it off, power back on. That implies the CPU was running code and it was trying to initialize the system, but there was just a whole bunch of garbage on there. This slow fall down here has to do with the fact this is set to AC coupling, and this cheap oscilloscope just slowly compensates for the AC. I don't know why it's so slow. Better ones, that would be instant. Okay, no CPU, no video signal at all. That actually is a good diagnostic piece of information. It tells us that the CPU is part of the video initialization circuit. Oops, probably has to do with this video chip here. And the CPU was doing something. Could we have a bad ROM? Possibly. Could we have bad RAM? Most likely. That's still my #1 theory for this, only because I've seen it before on these TI 4464 chips on 64s. Incidentally, the notch on the CPU is facing the slots and the ROM is facing away from the slots. But with deoxit, boy, that goes in so much easier. Right, let's just make sure we're back to where we were. Let's wait for this to come down. Uh-oh. We are not. Okay, I'm just double checking what I did here. The CPU is definitely in the correct way. The notch is right there, and the notch on the sub screen points the same way. But we are worse off than we were. Oh, hold on a second. I just powered it off and on again, and there it is. So let's just power this off and on again. Let's see if it does the same thing. Look at that. How, like, now it's doing nothing. This would be a total black screen Apple IIgs versus what we just saw a second ago. All right, let's get something plugged into the video output so we can actually see with our own eyes what exactly it is doing. Okay, here we are. We are on composite with the RetroTink. I do need to update the firmware. I know there's a newer firmware out for this thing. Let's turn this on. No signal. It says normal. Let's see what happens. Black screen. Let's just check it with the oscilloscope, though. Oh, did it just suddenly pop into existence? Oh, it's freaking out. It is freaking out. Also looks like it's in PAL mode. Well, that's strange. We can check this by going to status, probably 50 hertz mode, I am assuming. Yes, it is. V frequency, 50.32 hertz. So yeah, the 2GS does support PAL and NTSC output. And it's obviously kind of going wild here a little bit. While it's doing that little flickery thing, let's check what the oscilloscope looks like. Yeah, it looks very similar to what we saw before. But since I have the RCA jack connected, actually, this has a lower amplitude. Don't worry about that. That's just the termination resistor. But yeah, that pretty much looks the same, doesn't it? Okay, so what I have not done, the system is powered up right now. Let's see if any of these chips are hot. Those aren't. How about these? No. Failure mode of these chips is to get really, really hot. But those all seem fine. I mean, they're slightly warm. I can tell it's energized. Let's check all the other chips. I don't really know what should get hot and what shouldn't. These super serial chips usually get pretty warm when they're in the dip form factor. That one's kind of warm. Everything is pretty cool to the touch. One thing I'm curious about is I saw that when I turned on the power with the CPU in there, it still took a while before we got that kind of garbage screen. I just turned the power off. I'm going to pop the CPU out again. I just want to see if that garbage screen ever comes back on its own. Or is that something that's really coming from the CPU? So powered on the system again. And we do just have a normal black screen. Well, I think the next course of action, because this board is obviously crusty and was in a computer that was very corroded, it's probably worth taking out all the chips that are socketed. So that's just the graphics chip, the ROM, and the sound chip, and just deoxiding those sockets as well, just to kind of rule out that we don't just have bad contact. I don't really know what the 2GS does when these chips aren't making good contact. Like, I don't really know if the 2GS can work, for instance, without the sound chip installed. I have no idea if that is possible or not. But these sockets are super crustomatic, so that is definitely something I'm concerned about. Oh yeah, that is making crunchy noises coming out. So let's deoxide these dip sockets. Put these chips back in. May as well put the CPU back in as well. We know that is obviously required for it to operate. Just double checking that none of the pins are bent. Okay, they look good. And the last one to come out is the VGC, Video Generator Chip, I think it stands for. Had a lot of trouble lately with these not fitting. And this one seems like no exception. Like, it doesn't fit in the socket. It doesn't get around the chip. All right, I got one side of it in there, that side. So I pulled it out a little bit because the chip is super crusty. So any other way of doing it would be difficult. So I'm getting the other side in. Let's see if that works. Oh, there we go. Got it out. Okay, cool. There's our VGC. Pins look good. I don't see any corrosion on them. So let's put some deoxide in here. I think I have more of these PLCC sockets if I had to switch this out. Unlike the Atari ST, pretty sure Apple just used the standard type of PLCC socket. You can tell by looking at the bottom, and the pin array is just in horizontal and vertical columns. But on Atari STs, these pins are sort of like in a staggered arrangement. So you can't just use a normal socket. I'm not really holding out hope that this is going to fix it, but it's just good practice since we know that this machine is so crusty. Let me just double check everything is in the correct way. Notch, notch, and the notch is up there, and that is in the right way. Here we go, 3, 2, 1. Of course, you can't see or hear anything, but my presumption is this black screen we're looking at here. Oh, yeah, okay, it looks exactly the same. It seemed like just for a split second we saw a little bit of blue. We have absolutely no change. Cool. So this is actually going to be maybe a challenging repair, not just run-of-the-mill, oh, it's just, you know, a single bad RAM chip. I mean, it still might be that, to be honest. I just don't know. Okay, I think this calls for the big guns oscilloscope. I'm going to switch from this over to my bench scope so we can really start to dig into exactly what this 2GS is doing. And just to confirm, yes, looks exactly the same. Now, one thing I did notice is I turned this off and on a few times. Sometimes you get white, green, and purple boxes, which is very much a normal Apple II, kind of like I've crashed and not initialized myself situation. That's not happening now, though. I was doing that earlier off camera because I stopped to have lunch. And now it's not doing it again. I think we're just getting the standard black screen. On this scope, you see a little bit more of it. So that first thing is the color burst. Then we just have a black screen and we have the horizontal sync pulse. And those occasional low pulses you see are the vertical blanking that's happening. Well, I don't really have any leads on where to go, so we just have to do our normal troubleshooting and start from the beginning. So here's the CPU on the 2GS, and let's start with the reset line. It doesn't show that on the schematics, but this should be reset low, which is a / in front of reset or a line on top of it, but for whatever reason, Apple didn't do that. I do have the datasheet open for the CPU as well. Let's take a look at that reset input pin just to make sure I understand fully how it works. Reset is active low input and used to initialize the microprocessor. So yeah, when we turn the computer on, it should be low for a little while and then go high. That's just like the 6502, which makes sense since this is a 6502 type computer. Okay, the machine's off, turn it on. Yep, it was low, then went high. So reset's good. Next, let's look at pin 37, the clock input, Phi 2. All right, the clock is kind of staggered. Is this normal for the 2GS? Maybe, but it looks like when it's there, it's 2.86 megahertz, and then there are these parts where it's not clocked. This chip is a CMOS processor, and very much it is normal that you can actually stop the clocks on it, and it won't lose its registers and stuff like that. That's completely acceptable. So this could be like this because maybe the 2GS pauses the clock to the CPU while other things are happening on the machine, like it's accessing the video buffer or something like that. Let's turn this off and on and just see if that changes at all when I power it up. Oh, okay. Did you see that? It starts out at a lower clock speed, 1 megahertz, and then it bumps up to 2.0. And look how the gap in the clock is not the same now. So it's a little bit different. How odd is that? So we're getting a little bit of inconsistency going on here. Okay, there it is stuck in 1 megahertz mode. And there's no gaps in that clock really. I wonder if the ROM is trying to execute code and then it's getting stuck, and maybe it's getting to a point where it's starting to initialize the 2GS video mode and then crashes. Now, the reason why I mentioned this might be a RAM problem the whole time is the 65C816, just like the 6502, absolutely needs RAM to function properly. You can write code that doesn't need the RAM at all, so you don't need the 0 page or the stack. The thing is, most ROMs, and almost certainly the Apple 2GS ROM, is written with the 0 page and the stack working. So therefore, it's using instructions and it's using jumps and subroutines that use the stack and the 0 page. And when those are bad, the computer probably won't initialize properly. And maybe if the RAM is bad, it's just initializing in weird and random ways. I'm going to say that the clock is good, the reset line is good, we already know that the 5 volts is good. Let's take a look at the data bus. Now on this particular processor, unlike the 6502, the D0 through D7 is actually multiplexed with additional address lines, which is how the 65C816 can address more RAM than just 64K. So when we take a look at these lines, they should all look correct, but they might look a little bit different, at least when it's running in full 65C816 mode because of the multiplex address lines, though when this chip runs in emulation mode of the 6502, I think this operates much more like a regular 65C02 processor. So let's start taking a look at the data lines. I'm on D7, pin 26. There's nothing happening on here right now. Power cycle the computer, I assume we're gonna see something, and then it halts, or not, that time. Okay, well, it's running. Let me just go through all of these. So I'm on pin 27, 28, 29, 30, 31, 32, and 33. So all of these look totally fine. What I'm looking for when I say totally fine is, right now we're having a peak-to-peak voltage, around 5 volts-ish. If this was like stuck down low or it was held high at 5 volts all the time, that's where I would be suspicious that there's something wrong, maybe with an output driver on the CPU or something else on the bus that's causing some kind of a bus conflict. I'm just going to power cycle the computer again. Yeah, it's definitely doing stuff. The CPU is executing code. Oh, it looks like it stopped again. Ah, okay, this is weird. So let's check the pins again. So there's pin 26, 27, 28, 29, 30, 31, 32, 33. Okay, that all looks fine. Now, incidentally, even though it looks like it's trying to run code right now, there is no video at all. If we power this on and off, I wanted to try to get back to that screen where we had kind of flickering stuff going on. It's not doing it though. Let's take a look at these other signals that are on the CPU. We looked at reset. There's the VP signal, which I don't know what that means, and abort. Those both aren't on the regular 6502. We looked at the clock, that's good. BE as well, non-maskable interrupt, and then the regular interrupt line, and then there's ready. Okay, so the ready line, pin 2, that's just high all the time. And we turn the power off and on, it just goes high. Got to look up what that means. Ready is a bidirectional signal. When it's output, it indicates that the wait for interrupt instruction has been executed, halting operation of the processor. A low input logic level will halt the microprocessor in its current state. Returning ready to the active high state releases the microprocessor continue execution for a wait for interrupt instruction. Basically sounds like when the ready pin is high, the processor should be executing code, and certainly it is just high all the time. And the ready signal goes off to other areas of the schematic, specifically page 7, I suppose. And it is hooked up to this IC, which is what? The FPI. Now looking at the FPI, I didn't know what this meant. It looks like it has something to do with DRAM. I have a feeling like memory size, 1 meg. Probably this goes off to the RAM expansion slot, DMA, and probably talks to some of the other chips as well. But yeah, definitely the RA lines, this is going to be the DRAM stuff. So there it is, DRAM. So that chip specifically is responsible for the CPU's DRAM interface. Now 128K of the DRAM is going to be right off the Mega 2, and the other 128K that makes this a 256K machine, which is the stuff that's over here, this is going to be this DRAM here. This is the fast RAM, it calls it, UH15, and that matches right there. I hooked up to a random RAM chip on pin 2, which is one of the data lines, and I see there's activity there. Now, one of my issues with troubleshooting the system is I don't really understand at all what the ROM is doing when the 2GS initializes. This isn't normal Apple II, right? It's actually initializing probably some of these extra custom chips. And I don't think I've ever seen a disassembly of the Apple IIgs ROM to kind of understand the boot instruction flow, kind of like when I was troubleshooting the 3000, trying to troubleshoot the yellow screen of death issue. What exactly is happening when this thing turns on, and where might it be getting stuck? Let's focus our attention back on the CPU. Let's look at this abort pin. Let's see what this does. That's pin 3. It's just high, and if we power cycle the computer, see if it does anything but go high all the time. It is pulled high. There's a pull-up resistor right there to 5 volts. The abort negative pulse active input is used to abort instructions. Negative transition would inhibit modification of internal register, blah, blah, blah. Okay, I don't know. I don't think it really matters. It seems that when it's high, that is the correct state for the CPU to operate, that is, and that's all we've ever seen here. It has never done anything but be high. Okay, next thing was the VP pin. Let's see what that is. The vector pull active low output indicates that a vector location is being addressed during an interrupt sequence. I don't think this is really relevant either. Okay, so that is just high right now. Power cycle the computer. It doesn't really do anything. Where is that hooked up to? It is only hooked up to the FPI chip. Incidentally, Phi 2, the clock that goes into the CPU, remember how we saw it getting stretched? That goes into the FPI chip. But let's see where else that goes. Well, what is generating that clock? Here it is going into the memory connector. Well, that means it must be generated by the FPI chip specifically. And right now the clock is doing that 2.8 megahertz thing with this big gap in between. And would you look at that? We have some of that Mega 2 junk on screen right now. So that's what I was saying that it can do sometimes. If we power cycle the computer, let's see what it does. Just comes right back immediately. Now the Mega 2, as I mentioned earlier, that's actually like the entire Apple IIe chipset, all in one chip. I'm oversimplifying that there. This is going to have the DRAM hanging off of it that's used by the regular Apple II, which if we look at the schematic, that's right here is going to be 128K of that. But it does not contain a CPU. It still needs the 65C816 or 6502 processor to operate properly. It does generate all the DRAM refresh that goes to the primary RAM, and it also generates RGB output that then is, well, processed by the VGC chip, the video graphics controller. And if we probe these test points, then we should be able to see any kind of text that the Mega 2 is generating before it even gets to the VGC chip. Address lines 0 through 15, these are the address lines that go to the 65C816. That's just the normal 64K address space. And then we have data lines 0 through 7, which also go over to that CPU. And then MD 0 through 7, these are going to be for the memory data bus. Pretty sure MD bus, if we follow these over, then they will make their way over to these chips right here. Yes, they're right there. Okay. So because I suspect, but really have no proof of the fact that I think maybe there's a DRAM problem in these first 4 chips, let's take a look at these data lines that are going into the Mega 2. Okay, so that's pin 2, and then there's pin 3, and the chip next door. It's that one. That one certainly looks different, doesn't it? Oh no, it doesn't. That looks the same. It's just that one pin looks a little different. There. That one. These are two. The data lines are parallel between these two chips. So, okay, I mean, everything looks fine. I was just looking for any lines that are like stuck low or in a weird position. And then 15 and 17 I got to look at. Okay, there's 15 and 17. That looks fine. 15, 17. That looks as well fine. And these are going to look the same because they are paralleled with the other two chips. So data lines all look fine. I don't see anything out of the ordinary there. Now let's take a look at these address lines. It looks like 6, 7, 8, 10, 11, 12, 13, 14. Why is it all out of order? That's weird. I don't know. Maybe that's the way these chips are wired up. Okay, so 6, 7, 8, 10. I'm just looking for anything that looks weird. 11, 12, 13, and 14. They certainly all look fine to me. I think these lines are paralleled between all of the chips. Yes, they are. So yeah, okay. All the address lines look fine. Data lines look fine. Let's quickly take a look at RAS-CAS and the read-write pin. Okay, read-write pin. So it is just reading from the DRAM right now because it's active high. Let's power cycle the computer, see if it tries to write to it. Okay, yes, there are some writes. Okay, lots of writes. It's still stuck in a situation where it's trying to write. Oh, it gave up. Oh, came back. All right, so that is the RAS line. It looks fine, and that is parallel to all the chips, but the CAS line is not because there are two banks of RAM. So pin 16. So there's one, so that's one CAS line, and this one should be the same. And then the other bank has a separate CAS line. And that looks fine as well. All right, well, I don't quite know where to go at this point. I'm wondering if I should just see if this ROM is working, because the computer does seem to be trying to execute code. And the question is it executing code but getting stuck because there's some other problem with the RAM or somewhere else? Or are there other hardware issues, like with some of the main custom chips? That'd be bad. Or do we have a bad ROM? So maybe what I should do is just try to read this out. And I can always put a OneRom in this machine and see if, I could put some custom ROM on here that could give us more information, the kind of thing I normally like to do. Load a diagnostic ROM onto something. This is the ROM from this, and I just looked up the part number 342077-B. This is definitely a ROM 01. And I read is 128K EPROM, but people are like, you can't just use a standard EPROM in here. But a 27C512 is a normal 128K EPROM, and I mean, on first appearance, everything looks fine. Wait, there's an extra address line on the 2GS? That's odd, but it's wired up to basically like the chip enable line on the 512, so that's okay. Let me just go through, I'm just going to go through these one by one, and I'm going to mark off that they're in the correct position. So like this, just one at a time, Q0, pin 11, Q0, pin 11, and we'll just kind of go from there. Okay, so like Kevin validated that ground and VCC is in the same position just because it's not shown on the schematic, but everything else is exactly the same. What's not clear because Apple didn't put on their schematic whether these signals are active low or active high. Well, I'm assuming the circle actually means that it's active low, which is correct. Chip select is active low on the EPROM, as is pin 22, which is like the output enable, or other way around. I think pin 20 is output enable, and then chip select is pin 22, and those have the circle, so I'm assuming it means active low, and that means that 27C512 should just work in here. I did a quick Google search, and maybe it was talking about the ROM 3 boards not being compatible, or ROM 00 boards or something, but I'm pretty sure an EPROM should just work in this. But I'm also wondering, because I want to try to read this ROM chip in my EPROM programmer, and just setting it to 27C512 just can help me validate that the ROM image that's on here is good. TL8663G, or whatever it's called. I already have it set for that because that's what I was working on last. We're just going to turn off check ID, and we're going to hit read and see what happens. Okay. Well, there's stuff here. Whether this is correct or not, I don't know. This is the ROM chip that I read from the 2GS, and this is one I had on my hard drive. So far, they seem exactly the same, but we'll do a data comparison. File size is different. Oh, okay, I get what's going on here. 512 or 27C512, it's a 64K EPROM. It is not 128K, and that is why that extra address line 16, was going to, well, what was one of the chip enable pins on here. So it looks like what I've read out of this chip is the same. So like this was the last bit I was able to read from it. using, well, just putting this chip in here as 27C512. If I really want to compare the first half of these, all I need to do is just delete this second half on this file I just loaded. I won't save it or anything, but now they're the same size, and we can do a data comparison again. And there we go. So the files are identical. That means that what I read out of this chip is totally fine. For an EPROM that's 128K in size, it's actually 32 pins. This is only a 28-pin socket. And that's because, of course, they reuse that extra pin for that extra address line. But I wonder if this is something that OneRom could do. Could I use a OneRom to replace the ROM on this board? I don't think the ROM itself is the problem, but I'm just wondering if I could try to load like my Apple II dead test ROM into a 2GS. What exactly would that do? Maybe it would work. I don't really know. And here's the OneRom webpage. This is an EPROM emulator. If we have the Fire, which is one of the various types of the OneRom, let's just pick C, Raspberry Pi 2350. That firmware is 23C1000 ROM. Active low. Is that it? Let's look up what that part is exactly. 23C1000 pinout, 128K mask ROM in a DIP28 package. I think this is it. Oh, that didn't work. And yes, there it is. Pin 22, address line 16. All right, the OneRom's gonna work for us. Very cool. Here's one of the OneRoms. Raspberry Pi EPROM emulator. Pin 1 is right here on the top corner, and let's just make sure we have this in the correct orientation. There's the notch, and it goes into the board like that. This is pin 1, and the notch is silk screened on the bottom edge. So to program this, we're just going to plug in this USB-C cord like so. There it is. The 2GS is off right now. I have a few different ROMs to pick from. Let's just pick ROM 1, but I also have 0 and then an alpha version of the ROM. I don't know, we'll go backwards in time. Maybe there's more diagnostic information from those older ones. Let's try ROM 1 first. And I think this should all work. Yes, active low on chip select 1. All right, here we go. I just hit program, and there it is, connect. It's programming the chip right now. It's that freaking easy, complete. Pull this out, and let's turn on the computer. It's doing nothing, and the LED's not on, and I honestly don't remember if the LED should be on when the system is powered up, which it absolutely is. But I suppose what we can do is we can just check the data lines and address lines on the chip, just make sure that it's actually like reading code out of it. Okay, so that's looking like the CPU is just not doing anything. Yeah, that pretty much screams we're dead in the water. Let's take it out, see if that looks any different. Okay, so I turn it on now. Yeah, see, it looks the same. That's pretty much the CPU being like, no, I'm not happy at all. I am not working. All right, well, I'm gonna have to reach out to peers because I think I blew up the other OneRom. It does not work now. So when I plug this in, I get a very faint red LED and the computer detects it, but this is the one I was using in the computer, and I plug this in and it does nothing. Doesn't smell burned or look burned, or nothing seems the matter with it. And I definitely had it in the board correctly. There's a dot right there for pin 1, the notch is right there, and I had it in the board this way. But this OneRom seems to have not survived being inside the Apple IIgs. Interesting. I'm going to put, for now, I'm just going to put the dot of shame, just so I can tell it apart from the non-dead one. Let's put the original ROM back in, and I'm just going to check the voltage levels on the pins that I expect to have voltage. Okay, so we're getting the flickery thing again, so at least that's back. And according to this, pin 28 should be VCC. Yes, it's up at 5 volts. And pin 14 is ground, which is this pin. And it is. So I'm not sure what I just did to that OneRom that took it out. But that is what you would expect for VCC and ground. And with the blown up OneRom in the board, we turn this on. This should be 5 volts. It is. And this should be ground down here. And it is. And this pin here, we're getting 3.3 volts, which I think is normal because that's what the Raspberry Pi runs at. So it feels like the voltage regulator is running on this thing. It's just my understanding the firmware that runs on the OneRom does turn on the LED. It's like what controls the LED. So the fact that we're not getting anything on the LED tells me that maybe there's a firmware problem. All right, well, anyway, let's try again. The only thing I think maybe I did wrong is I picked Fire 28C. It's like a revision, and maybe this is an A board, because these are old. Like, I've had these from Pierce since last year. So I'm just going to try again with the A firmware, and we'll see if that changes anything. Program, pick that, hit connect. Maybe there's some kind of unbricking or recovery process I can do. Okay, so I'm going to unplug this and plug it back in. Make sure that the light comes back on. It does. So that means the firmware is working on this thing. Make sure the computer's off. It is. Let's get this into the board. I want to at least see the same behavior that we were seeing before. Okay. So now if we turn this on, oh yeah, the light comes on. So that was different on the other one. Oh yeah, okay. So we're getting stuff. This is normal looking on the CPU. And there we go. We're getting the flashing. So, okay, good. That means the stock firmware is not bad on this ROM, and it is working, obviously. Okay, so we're going to try some of these other ROM images first. We'll try 00 next. We hit build, program. It's that easy to reprogram these. It is so handy. By the way, there's no danger if you do try to turn the computer on while it's still plugged into USB-C. There's diodes and stuff that protect it, but we'll try it anyways like this. And black screen. Okay, so no actual change. Okay, and I went ahead and I programmed that alpha firmware on here, which I don't presume is going to do anything. And yeah, it doesn't do anything. I guess let's make sure that we actually have activity. Let's make sure we actually have activity on the CPU. Not really, actually. Looks like this firmware does not work. I mean firmware by the Apple IIgs firmware. Let's put back on the stock firmware, active low, build. I mean, this doesn't really seem like it's working either. It almost feels like this is just dead. Oh, look, we're getting the garbage from the Mega 2. Now the question is, let's turn it off and on real quick. Oh, man, it's gone. Darn it. I wanted to kind of see if that would come back really quick, because I wanted to then take the firmware off or take the firmware chip out. Okay, there's a bit of garbage. What I want to see is if I pull this out, will we have the garbage there? How do I test this the quickest way? Oh, whoa, weird. That's just happenstance, I think. Okay, I'm pulling the ROM chip out. We've only ever seen it do a black screen with no ROM or no CPU in there. I just want to know if potentially that random Mega 2 garbage can happen anyways. But maybe not. Yeah, maybe not. Okay, one thing I'm curious about, it's powered up right now. Let's see what the clock speed is running at. Definitely starts at 1 megahertz and then switches into fast mode. So it feels like the CPU is getting instructed to do that by some code. And then it gets stuck. Now it's like jumping back and forth. Okay, now it's just stuck at 2.8 megahertz. Okay, so I'm going to try something that I don't know if this is even going to work remotely, but I don't know, might as well try. I'm kind of stuck anyways. So the Apple II Dead Test ROM, it's a ROM I worked on with my friend David Giller. It's for the Apple II and the II Plus, the camera on the IIe and the IIc, and it just tests that first 48K of RAM on the Apple II with a March U RAM test, which is really good at testing the RAM, but it also is able to do its first initial phase of RAM testing without actually needing the stack or zero page, and then it should beep out an error code if it's stuck. Well, I have no idea if it's going to work on the 2GS because I don't understand what the 2GS does to initialize its hardware, but maybe it will work. I don't know. When we take a look inside the releases here, here's the ROM itself. It's only 2K in size, so if you have an 8K EPROM, you're going to have to copy this over and over again. It was really designed for the Apple II and II Plus, where it just goes in a single ROM all the way at the top of the ROM space. Well, in the 2GS, we have 128K ROM, so I just went ahead and made a file that's that same 2K file, just copied 64 times, and it's this one here, output 128K. We can just open this. Let's program it into this chip and see what happens. Build firmware and program. All right, so the chip is programmed. Let's get the oscilloscope probe onto one of the pins on the CPU, and we turn it on. I mean, it's doing stuff. Let's check the CPU clock. It should be stuck in 1 megahertz mode, and it is, because this never does anything to like make the thing go faster. I don't know if that's normal execution. Doesn't seem like a lot of activity. I would expect more. but maybe, I don't know. Well, you know what we can do? Let's power cycle it and just see if it's random every time or it looks the same. I guess that kind of looks the same, doesn't it? All right, let's just see what it's going to do here. I have no idea. The system is off. Let's power it on and let's see if this is actually doing anything. No, it is not. I mean, it's not outputting anything at least. I just hooked up a speaker just in case it is actually making some kind of a beep, but I doubt it. Okay, yeah, no, we're not getting any kind of operation of this system whatsoever. So it goes without saying that I am stuck here. I've sort of tried all the things I can try on this machine before I start like pulling chips off of it. I do have another 2GS motherboard around somewhere. I can't remember where. I think it's in my storage unit. So I might need to go grab that, and then I can at least test the OneRom in it just to make sure 100% that the OneRom is working in the 2GS. I have a feeling it is. And then I could also test to see what this dead test ROM does on the Apple IIgs just as an experiment more than anything. And I think I'm going to do that thing I do where I'm just going to edit up the footage I have so far on this diagnostic, see if anything kind of pops into my head, maybe sleep on it, and then try to revisit this. And hopefully I can, well, I have a brilliant idea of what to check next before I just start pulling chips off of this thing. And by pulling chips, I mean taking off the main standard memory, which is obviously going to be essential for the initial booting of this machine at least. All right, so I'm still sitting here at my desk and I basically closed down OBS. I stopped recording and then I was reading something on my screen and the 2GS was just turned on and the speaker went bloop and made a beep tone. It made the tone that the diagnostic ROM, the dead test ROM makes when it's running. So I almost think that this thing is actually running the diagnostic ROM right now. Maybe we just can't see it because the Mega 2 is outputting the video, but the VGC is not configured to display it through the composite video, something like that. Now, what I haven't done is switch over to the composite output. Let's see what we see on there. It just beeps again. And yeah, I just heard that. Look, this is what it does when it's running. So you can just run the dead test ROM on the 2GS. Now, it's supposed to give us a text mode kind of like status screen. I'm shocked here at what's going on. It was sitting there for a while before I heard the beep. Also, this speaker that I have hooked up here, which is not the original, is very quiet. I don't know if the speaker is bad, or maybe the 2GS sound output is bad, or maybe the volume is just set to like 1 because it's not initialized yet. Now, this does not look correct the way it's checking the RAM right now, but this is the typical RAM check. I'm shocked. I am totally shocked. You know what's kind of funny here is that it's possible we could just like copy Apple IIe ROMs onto this machine and it might work, or like Apple II Plus ROMs. I mean, this thing targets the 2 and the 2 Plus, and you can see. Okay, so it should be showing like the status screen right now. It should show like you know the banks of memory and like where the problems are, and then it loops. Okay, I placed the microphone right next to the speaker. Did you hear that little beep it made? That's the tone. Let me turn this off and on and listen very carefully for any kind of initial power up beep. I certainly don't hear anything. And why aren't we seeing anything yet? Like, it's very odd. Like, it was running the diagnostic. That's what we were just looking at. And yet, every time I turned this on before, this is all we got, black screen. I guess I'll just sit here for a moment and just watch it and just see how long it takes for something to happen. This is where if I had my spare motherboard, it would help because I could, it's working. I could put the OneRom in it and see what the behavior of the diagnostic ROM in that is. Does it take a long time to run? When it runs, does it give us like that kind of screwed up screen instead of the whole screen just filled with test patterns? Those are all questions that I don't have the answers to because I've never tried any of this. But yeah, it's like not doing anything right now. And normally this ROM gets into that phase we were just looking at very, very quickly, like within a second on the normal Apple II. And here it's just sitting here doing nothing. Okay, I banged it. It gave us a bloop sound, and now it's running here again. So it's almost like it goes through an entire phase, the first phase of the diagnostic, and it never actually initializes the screen, not until it tries to switch over to text mode from graphics mode. And that's what the status screen is, where we had all the @ symbols across the whole screen. It makes the little very quiet bloop sound. Very curious here. Very, very curious. But yeah, my assumption is if we power cycle the computer, it will, I mean, it should make a sound right now. I think that's what the stock Apple II will do, but it doesn't do anything. But there's a whole bunch of soft switches inside Apple IIs, and the ROM manipulates those, but of course it's targeting those old Apple IIs, like I mentioned, not the 2GS. So maybe we're leaving certain soft switches out, and that way it just can't display anything until it goes to try to go to text mode, and that gives us all the @ symbols, which is wrong. It should have the text mode. But it's possible the RAM is bad there, and when the ROM is trying to write into the text page, it's not able to actually do that. Of course, it could be the Mega 2 that's bad. You know, we could have other issues on this board. But I'm still amazed that we are getting a sign of life out of this diagnostic ROM. But yeah, I think it's going to go through the entire first phase of the March U test through all 48K of RAM. That's all this tests, 48K. And then it gives a status screen with the bloopy sound, which we hear faintly. And then it switches to text mode, and then it kind of goes and it will just loop indefinitely. I'm refreshing my memory by just reading the GitHub repo. When RAM is detected that's bad in the 0 page or the stack, you actually get specific beep codes. And that's initially, like when you first turn it on. If it doesn't detect any kind of a problem, it will just start testing all the RAM, which is what it's doing right now. And at the end of the main memory test, the ROM will display a grid of all the results, which looks just like that, and play a tone. A low tone indicates there was a memory fault found, but a rising 2-tone beep indicates no problems found, which is what we're hearing. I'm hearing like low-high. The RAM test is passing right now. I mean, at least it thinks it's passing, even though visually it's not passing with the way it looks there. And I guess right here, look, a full test of the 48K RAM takes 1 minute and 30 seconds. So that's obviously that first phase before we see anything on screen and before we hear that tone. That's that minute and 30 seconds where I thought the machine was bad and I just looked away, and that's when I heard it and it like clued me in that it's actually running. Well, I'm back from editing upstairs, and the 2GS has just been running the entire time. Power supply is pretty warm, but actually not that bad. And you can see that it's still running. I've just been doing a little bit on my computer before I started OBS, and I've been hearing it beep away. And so the machine is not crashing. The dead test ROM definitely thinks that it has a good 48K of RAM, and there are no issues with the RAM at all. So whatever's going wrong with this computer, it's somewhere else. At least it's not in that main part of the memory. So let's try a little bit of experimentation. I have some other ROMs for us to try. How about an Apple IIe ROM that's duplicated all the way up to 128K? Let's see what this does in this machine. I don't know. I'm kind of expecting that maybe we'll hear a regular Apple IIe beep out of the speaker, but let's give it a try. Here we go. No beep. Oh, I heard a beep. I heard the normal Apple II beep. It just took a long time. Why did it take a long time? And obviously I'm not seeing anything on screen. How about we try Apple IIc ROMs? Because it's got an integrated WAS machine, which probably exists in the same exact place as the one on this machine. So maybe it'll even be able to boot software. I mean, I still can't believe this even remotely works at all. I mean, we're not seeing any video on the screen, but that could be a soft switch setting. I just need to manually, type on the keyboard and make work. I don't know. Okay, here we go with the Apple IIc. I'm going to listen. Okay, I don't hear anything with the 2C ROM. Now, I just took the regular 2C ROM and I copied it multiple times to make the 128K. And maybe that doesn't quite work, but with the Apple IIe ROMs, there's a CD-ROM and an EF-ROM, and I copied that multiple times, just like I did with the dead test ROM. Let's go back to that one, since that one at least had a sign of life, and I can try blind typing some commands to see if we can get any kind of display out of this thing. My assumption is that the Apple Desktop Bus keyboard, if I plug it in, it's going to work exactly the same way that the stock Apple IIe keyboard works. That way all software, like even the ROMs, doesn't really know the difference. Okay, let me turn this on. It doesn't beep right away. Well, oh, there it was. I just heard the beep. So unlike the 2C ROM, that just takes that amount of time for it to initialize, which is weird. It's way longer than it should take, but I don't know. I don't know. Something's going on here, right? Something's going on. All right, so what I've just done is I have connected this Apple Desktop Bus keyboard to the machine. It's plugged in right there. Yeah, this is just a S-video cable. Let's see if I can blind type some stuff on here. Okay, there was the beep. I'm going to hit Apple Control Reset. Open Apple, that is. Yes, it's beeping. So it's definitely doing something. So on this Macintosh keyboard, Apple Control, and this is the reset button right at the top here. Let's type HGR. Well, hit Control Reset. HGR. No, GR. Just beeps at me. Oh, caps lock. This is an unenhanced Apple IIe ROM. GR. Oh, look, look. We have actual... This thing is responding text. Yes, it is doing stuff. For me, there's a few revelations here. First off, you can run an Apple IIe ROM in a 2GS and it works. I mean, that's kind of shocking. I would have never suspected, but I mean, I knew the compatibility of this thing was really good. Second of all, this machine, which is broken, is showing signs of life. Let's hit Control Reset. Yep, and then HGR, and then I can hit Control Reset and I can get out of there. Now, I don't think it's necessarily, well, we're having the same issues where we're looking at the wrong text page. That could be a problem with the soft switches, like they're just not configured correctly on this machine. And it's odd that when you first turn on the computer, A, it takes a while before it even boots, so that's weird. But the fact that it's responding to AppleSoft basic commands tells me that there's enough memory working on this thing for even the stock 2E ROM to allow this machine to initialize. Now, I can hear people asking the question, maybe the stock ROM was working and we got that graphical corruption. What if it was just a graphical issue? And now that I have a keyboard plugged in, maybe if I'd hit, Control Reset, I would have been able to break out of that. I mean, we can certainly try it, but I really don't think that's the case. And the reason why I say that is because we saw the clock speed when we looked at the CPU and it was different. Every time I turned on the computer, it was just not acting consistent. And when you have a lack of consistency, that really implies there's some state that the machine is getting into that is unhappy and is breaking. Okay, I just programmed the 2GS stock ROM back onto the OneRom. Turn this on. Not really getting anything, but that doesn't mean anything. It's hit Control Reset. Oh, the hissing noise that I heard initially, I thought the power supply, it is coming from the speaker. Okay, Control Reset. What? What? I could have maybe gotten to this point before? You're kidding me. There was the normal dong out of this. Listen. So, I mean, we're actually kind of working here. PR number 0, PR number 3. I'm trying to do stuff. I figure that it should just be at the basic prompt here. HGR? No, this doesn't actually seem to be working. This is working worse. I'm going to hit Apple Control Reset. And now just Control Reset. So we should be GR. No, it's not accepting commands. Pretty much that should have dropped us into the basic prompt right now, and it's definitely not. Fact is, we are hearing sound and the system is kind of working. Oh, I just had a thought. The 2GS ROM has built-in diagnostics. You hold down both Apple keys, and in this case, it's Option, Command, Control, Reset. There it is. It's running the diagnostics. Now our issue is that when there's a fault, it actually prints the fault in text mode, and I don't think that's going to work. And that's specifically because clearly text mode's not working correctly. We're on the wrong text page or whatever. Okay, that was horrible, like a high-pitched squeal coming out of it. Is this the screen that should be showing us the error right now, and it's not because obviously the text mode is broken? I think so. I think so. Now, right now we're in text mode. If we actually had RGB hooked up, the border wouldn't be gray. It actually would have a color. The color killer is enabled. That way there's no color fringing on anything, so there's no color burst. That's what the 2GS does on the composite output when you're in text mode. But when it's running the diagnostics, it has a graphical screen that's going through its phases there, just sort of a bunch of junk that's showing up, but it makes it show up in color. You get to see the border colors. Right now, the color is enabled. That's why I have a purple background or purple border. Then we get green and the green, and then it goes to gray while the color is still enabled, because we're going to see graphic mode for just a second, and then it's going to give us that screech. Yeah, so there was color there. So it was dark gray background. What is running while it's in the dark gray background? Wow, I'm amazed. I never would have thought that the computer was actually working to the extent that I could have broken out of that state. If I power cycle it now, I mean, it's still broken here like this, but let's try doing the reset. Oh, there's the garbage. Look at that. And we actually had some letters there. Now, from my understanding, by the way, I just have to add this, that the control reset through ADB actually is giving a hardware reset. So the CPU should actually be reset by the keyboard right here. And I guess I figured the entire time that just power cycling it would have done the same thing. So instantly it goes to this. Oh, that's weird. I hit control reset with no modifiers and it went straight into the diagnostics. Remember one time, and I know it made it into the video, we actually saw like some colors appear on screen, like solid colors just like this. And then I wonder if that was somehow it kind of getting into this diagnostic mode on its own. So now it's not doing it. Let me power cycle the computer one more time. This is fascinating. This is such an interesting fault. So control reset. There we go. Now if I hold down both modifiers and control reset, there we go, diagnostics, and trying to boot out of there. But unlike the Apple II EPROM, we cannot get into any kind of mode where we can do anything. Okay, I've gone back to the Apple II EPROM. So if I hit control reset now, yeah, I hear the beep. Still weird how there's that pause when you first turn on the computer, but let's see if we have actual control. Yeah, we have control of the computer right now. PR number 3, high resolution. Yep, there we go. We're in 80 columns mode. I have an idea. Because I was able to type PR number 3, maybe the floppy drive controller is working and I can plug a disk drive in and we can boot something. Let's try that. All right, so I have an Apple floppy drive, an actual floppy drive. It's not even a floppy emu. Let's see what this does. Can I actually boot disks off this Apple floppy drive here? Okay, here we go. Let's power it up. Disk drive's not doing anything. I haven't heard the beep yet, though. There was the beep. Okay, PR number 6. No floppy drive action. Now what I can do is I can actually plug a floppy drive controller into this computer, because what if the virtual slots aren't working? Obviously slot 3 is, because we were able to go to 80 column mode. PR number 3. Yep, there's 80 columns. But PR number 6 didn't work. Let me grab a floppy controller. Oh, you know what? While I was looking for my Apple II floppy controller, I found this, which is my Apple II VGA card. This snoops the bus and watches activity, and maybe in a 2GS, it can actually output video if the video subsystem is not working, especially with the Apple II EPROM in here. Let's try this. So I have it plugged into slot 7. This is the capture device, the Extron 300A, and let's see what happens. Let's make sure we're on the right input. Yes, we are. Okay, are we ready to see how this goes when I turn it on? Here we go, 3, 2, 1. Okay, that's normal because it hasn't booted yet. Okay, I heard a beep, but nothing. Oh, look, it changed into graphics mode there. If we go to text again. Huh. Very interesting. HDR, I mean, that works as well, but it's not able to really clear the screen. Now, the text you're seeing there doesn't match what we saw on the 2GS's output. That's because this card, what it does is it recreates the entire frame buffer and font generator and all that stuff inside the card. It feels like the system is not writing into the screen memory in the correct location, that even this card wouldn't be able to see it. When any program or ROM or whatever is running, it's writing text updates into the main memory, and then that's what the display hardware shows on your composite video output. This card snoops those writes over the bus. It seems that for whatever reason, the CPU is not writing into the correct location. And well, it obviously wrote some of the stuff correctly, because we saw a few lines appear when I did HDR, like I could do text and HDR. It's supposed to clear the screen. All that garbage should be cleared, but only a few lines are cleared, not the rest of it. And remember when we were running the March RAM testing, it was acting similar, where I saw part of the screen look normal with the test patterns as the pattern would fill the RAM, but then a bunch of it was just sitting there not filled. Felt like part of the RAM was being written to properly and part of it wasn't. But the strange thing is that it's the CPU that's writing into the correct locations. I don't know. I just need to really get my head around like the visual symptoms we're seeing on this card versus the composite video, and the fact that like PR number 3 works, but PR number 6 doesn't. Let me still get a floppy drive controller. I just want to see if I can boot a game or something on this. That would be the ultimate test. Okay, I have a floppy drive controller. I'm going to plug that into slot 6. It's plugged into a floppy drive, obviously. And here we go, 3, 2, 1. I know it's working because I can hear the beep, and I'm able to issue basic commands. PR number 6. No. I can confidently say what's happening is that the internal floppy drive controller is still enabled, because you have to go to the control panel to turn that off. And I don't remember if any of the slots are disabled by default, but I'm going to try slot number 7 here and just see if that is. Okay, I'm back on the composite video. PR number 7. No, that doesn't do anything. It's my recollection that slot 1 is like the modem port, then printer, or vice versa. I can't remember. PR number 3, that's the 80 column card. 4 is the mouse port. 5 is the 3.5-inch floppy drive. 6 is the 5.25-inch floppy drive. And 7, I think, is Apple Talk by default. And that's why none of the slots are actually working. Now, when it comes to the 80 column card, this just snoops the bus and doesn't really matter. But I'm going to try plugging into slot 3 and see if that makes any kind of difference. I don't think it will. I'm sure it'll look exactly the same. Yeah, basically exactly the same. GR. Yep. HGR. HGR2. Oh, okay. So that's the second graphical page versus HGR, which is the first one. That's why it looks a little different. HGR2. Couldn't really write to that one either. GR. Oh! There's some actual text on screen. I mean, that looks like the machine language monitor. Is that even a command? That's not a command. HGR. What? Where was that coming from? So I was on HGR2, and then I typed GR, and that's what we saw. Where's that text from? That is without a doubt the machine language monitor right there. Without a doubt. PR number 7. When I did that, we saw a little flicker. It's like the addressing is just all screwed up on this thing somehow. Although PR number 3 works. Well, didn't work there. PR number 3. So that's working. Now, of course, we're looking through this card. We're not on the true output. Let's go back to the composite video. I think I typed GR. And there's that text. So the character generator works on this machine. It's just somehow, well, at some point that got written into the buffer in a weird spot. And I'm assuming that was from before. And the machine, there's retention of the memory when I turned it off and on. So if I just turned it off for longer, turn it back on. I know I feel like I'm flailing around here. I'm just trying to collect information about like what the exact symptoms are on this machine, just to try to help me ascertain exactly what the fault is. Okay, so I did HGR2, and then I typed GR. So now that looks perfectly clear, but I don't get it because the machine's obviously working. Oh, unless it's not working. And when I first turn it on, it's instantly crashed. That's probably what's going on. And somehow it's writing into the wrong memory location for the text screen, because we're looking at the second text page right now. Not the first one, but the second one. Now, this could be an idiosyncrasy of running the Apple II EPROM on the 2GS, maybe. But I think what happens is if I reboot the computer or I power cycle it, when you're in... Oh yeah, look at this. When I hit enter on now it's like making the screen flicker a little bit. I assume I'm still in basic. I am. But if you're in call 151, how do you get back into normal basic? Is it like Control B, enter? Yes, it is. Okay, so HGR2, and now we do text. HGR2, and now we type GR. Okay, that looks the same. All right, what I'm going to do is I'm going to power cycle the computer, and it's going to do that, where we get nothing. Control B, enter. HGR2. Okay, now we're in basic. Okay, look, there's a little bit of that, but that's nothing that I was typing. I just thought maybe what I was typing would have been there. But maybe, I'm just trying to figure out exactly what's going on here. Okay, let's try that one more time. So when I power it on, it sort of sits here for a while before it gives me a beep. And once I get the beep, there's the beep. Am I in the machine language monitor right now? If I hit L and we hit Control B, enter, HGR, yes. So I didn't hit reset, HGR2, GR, but it's just that same stuff there. I have an idea. Text page 2 is CO55. Call -151, CO55. Ah, so that's the second text page right there. And it's like, why is that junk there? And it was CO54 is page 0 or page 1. But like, how did that stuff there, which is clearly from the machine language monitor, make its way onto the second text page? Okay, I think I need to stop this video here. It's way too long. The machine has signs of life, but clearly we have something going on. This has got to be more than just RAM problems. It really has to be more than RAM problems, especially because the March RAM test, it works. And AppleSoft Basic, it's working. I don't know why the internal floppy drive is not working. Like, I have the floppy drive connected to the floppy port. I mean, it could be a bad connection with all the rust in there, to be honest. But I'm able to issue commands in the machine language monitor in BASIC. It is totally working. We got a little bit of text displayed on screen there, although none of it really makes sense exactly what's going on with that. There's some kind of address decoding problem going on. But then again, like I said, the ROM code is working, and March tests are very sensitive to detecting if there's any kind of addressing errors, and it was not detecting any. So the first 48K of RAM, according to the March test, is all good. But it seems that the Mega 2 is not able to read out of the RAM properly, even though the CPU is. Like, this seems like a problem between the Mega 2 and the RAM, and not the CPU and the RAM. So maybe I need to look to see if there's bus transceivers and stuff in the way. Maybe one of those is bad. Bad traces. I mean, it doesn't look like there's bad traces on this board, but there's so many possibilities here. So I'm going to end this video here. I'd love to hear from people. I have a little bit of fluff on myself there. I'd definitely love to hear if you have any thoughts about what's going on with this machine. This is a curious one. This is definitely not an easy repair. And thank you very much, Pierce, for making the OneRom, because it allowed me just to load ROMs onto this thing like rapid fire. Apple IIe ROM running on a 2GS, and it's kind of working. I mean, I have a feeling on a real 2GS, it might just work. It might actually just work. But yeah, this board is obviously broken. So gotta figure out what's wrong with it. So anyways, that's gonna be it for this video. If you liked it, thumbs up. If you didn't, you know exactly what to do. Huge thanks to my supporters to make it possible to do this full time. Their names go on the side of the screen. And I guess that is gonna be it for now. And yeah, stay healthy, stay safe, and I'll see you next time. Bye.